Cool. Hey, welcome everybody. Thank you for coming along. My name's Nick. I'm going to be talking tonight about publishing Python packages and some other stuff that might come in handy in doing that. Now, I was going to introduce myself. I'll do that for the benefits of the folks at home because I think most of the people here I've either known for a long time or met today. I spent a long time at UQ. I did various degrees ending up with computer science, and I spent a lot of time working with UQCS, and I always appreciate the chance to get back to UQCS, so thank you to the committee for letting me come back. After graduating, well, 3 months ago, I started a company called Canva. We make a design tool in which this presentation was made. I guess we'll start off. How many of you have run this command or something similar? It doesn't have to have been requests, but yeah. So pip is a very handy thing, and a lot of people go their entire lives without thinking about how pip came to be or how pip does what it does, because it feels like when you do this in the first couple of times, it feels like magic, and then you kind of get used to it. But pip is this an entry point to this massive infrastructure that you can go and see and look around in, I guess, a little bit more readily on the Python packaging index. So that's this website here, and you can see here they host an unreal amount of infrastructure. So all of the things that you install by pip come from this index, and you can see there's 300,000 projects. That's when I was at PyCon a couple of years ago, they were celebrating having reached 100,000. So it's growing exponentially, and that's in addition to the amazing standard library that comes with Python. This access to all of these packages that people have gone and written for various use cases. A lot of them won't be relevant to you, some of them may be, but they save you so much time. That's why they call Python, in addition to that standard library, a batteries included kind of language. Now, I started playing around with this at PyCon 2019. I was talking to some people about and watching some talks about publishing, about getting like people who maintained these big projects, and Russell Keith McGee and the Beware project. I got started contributing to open source through that kind of thing. And I decided at PyCon, I think it was the middle of the second day, I was going to write a Python project, a Python library, and what came out of it was this project called Slackblocks. There was some functionality that I wanted in the UQCS bot, particularly for the events command. It was a tiny little thing. I can show you, see here the little blue styling down the side. It's a deprecated feature, but it's still readily available in Slack. But in order to get access to that, you have to create this disgusting, awful blob of JSON in order to unlock that functionality. So I decided, well, this is crap. I can generate JSON. Writing JSON is not for humans. And over the course of the weekend, I put together sort of a proof of concept. All it is some Python classes that have a special method called generate or resolve, and what that does is just turn that class, it serializes it. It turns it into the JSON that's required and puts it all together. So you can create messages. Messages have section blocks or image blocks, and those blocks have attachments. And it ended up becoming quite interesting. Just not even the code. The code isn't particularly interesting, but all of the stuff that happens around the code, the publishing itself, is just a very interesting place. And there's this environment around it, and you can see like it builds up, and you can add to these projects piecemeal and communicate. You can do a better job of communicating, and eventually you can get to the point where now this is a bit misleading because a lot of the downloads of Python packages are by things that crawl PyPI and index them, but there are people using this. There's a big dispatch company in Hong Kong that uses this internally, and I've had pull requests from a number of people across the world, or people are looking for features and it's like, oh, this is going to take me 2 minutes, why not? Or people who just wanted to contribute. And I don't know, getting involved in that environment, in that, particularly when it's all open source and readily available, it just, I don't know, it feels good. It's a technological challenge. Again, not so much the code, but the infrastructure around it is really interesting. So there's a little bit of background to this. I got a little bit carried away. I meant to create a really simple demonstration app. The one thing I was going to include was decorators, because I've always wanted an excuse to write a decorator, but there are some things that you're going, if you want to understand it, and if you've only got sort of rudimentary Python, I guess I wanted to explain those first so you weren't feeling left behind. So the first thing is typing. I always write type Python now, so you, in order to take advantage, I guess, of advanced lookup features in IDEs, in order to verify that your programs are more correct, you can add these types. So here you can see that this first argument to a regular Python function is a string. The second one is a callable. A callable is just a fancy name for a function. If I was typing this properly, there would be some square brackets after that, and you'd define what it takes in as parameters, what it returns as its return type. And you can see here, it's got this little arrow and then the string, so it's returning a string. So here, it's calling that function, and it's returning a string with some additional parentheses around, apostrophes around it. So that's the first thing. The second one, as I mentioned, is decorators. So the decorators are something, it's certainly not unique to Python, but they're very commonly used. So if you use a web server framework, or like micro web server framework like Flask, they make heavy use of these decorators. So you can see in the red there, the app.route. So in Flask, that means that if you go to your domain / nothing, it's going to return hello world as text. And what that does is saves you from having to create a response object and send that back. This is how you write them. It gets a little bit tricky, and this is where I think I went wrong with this talk. I got a little bit carried away. This is how you create a decorator. So you are defining the thing that you're putting up the top. So in this case, it would be app.route is this hello function. And that takes a callable, a function. So that's when you apply this, so it on top of the function here is an application of the decorator to that function. So if you imagine hello world is going inside this app.route as an argument. And then what it allows you to do, the crux of this, you don't really need to understand, it's not what the talk's about, but I just thought it was really cool. And what it allows you to do is do stuff before the function, do stuff after the function, and it also allows you to sort of manipulate the output of or change the behavior of the function. So then you return this changed function. So when you go and use hello world, or in Flask, it gets called for you, this magic is happening. And the other piece that is sort of core to understanding what's going on, again, understanding the code that's actually making up the library is not important to this, but if you're interested, this uses ANSI escape codes. So it's what it is special characters put at the beginning of output to standard out or standard error or your logs or whatever, and it changes how that appears in a terminal. So those special characters get interpreted by your terminal, and you can do stuff like make the text colored, or make the background colored, or make it bold, or even make it blink if you want to. So this is just an example of sort of color combinations. This is a little bit more fancy than what I've done. I've focused on a much smaller set of colors and styles. Now, that's about all you need in order to understand what's going on. If you have any questions, of course, just reach out to me. So the library that I made, I wanted to have some code here so we weren't spending the time during the talk making the library. I decided to call it House Paint, and what it does, it's structured like this to begin with. So all I did was go to GitHub, I started a new repository. They said, do you want a license? I picked BSD3. They said, do you want to read me? I said, sure, why not? I'll fix it later. And then I added some files, House Paint. So House Paint takes sort of all of that stuff before. It provides decorators that change the color of all of the outputted text in a function. And I guess it'll make a little bit more sense once I explain it. So this is the core of it. This is paint. So this is the decorator, and it takes in some arguments. And I had to do some finagling around this, but it's again not important. So the function is what you're using it on. So the function that you're wrapping goes in as func. Your foreground and background, they are just colors. They're Python enums mapped to colors. Again, we can cover that. Styles, things like boldings, things like resetting all of the formatting, which is really handy when you're writing it just for a function and you want to clear it at the end, which is what you can see down there at the bottom. So it's going through, it's grabbing all the styles, concatenating all the styles together, and the foreground and the background, putting those in front, running the function, and then resetting so that it's not affecting behavior after the end of that function. This is I've removed foreground, but it's identical to background, except for some of the values have changed, but these are just shortcuts to access those values. So you can see, runs through the colors that you can use as backgrounds. You can underscore, blink, reverse. Depending on your terminal, some of these may or may not work, but it's just sort of a trial and error, and that's the kind of thing that you can pick up in testing if you're really motivated. This is the third one. I wanted some pre-mixed house paints, if the metaphor keeps flowing. And I've done something, again, probably not appropriate for this level of talk, but I've used something called partial. And what a partial does is it takes in a function, so paint in this case, and it takes in some of its arguments. What that allows you to do is take the success there and apply it on its own without providing any arguments. So if you're back here, some of these arguments were required. So the foreground, background, they were set as default, so that's not going to change the behavior. But here, by default, if you put success on there, you're going to get a green foreground, and it's going to be bold text. So if we see this like actually being used, we're importing the default paint object. We're providing some arguments to it as the decorator. And then we're calling print. Now, if you call print and you've got ANSI escape codes in there, I can't guarantee what's going to happen. But what happens when you call success example is that all of the text output of that is green and bold. That was harder to pull off in this fancy code formatting tool. Now, how do we ignore that for the moment? It looks a little bit scary, but we are ignoring this. Now these are setup.cfg and setup.py. You can use you can use one or the other, or you can use both. And that was how you traditionally set up packages. Now, for Python, you needed these two files and some way of defining your dependencies, whether that was a requirements.txt or something that's been introduced recently, which is a pyproject.toml. And we'll talk a little bit more about that in a moment. But the setup.cfg file is when everything is static, or when it's for defining the things that don't change. So you define static information in there, whereas the setup.py is just a Python file. You can go out and reach for dynamically if you want to a version number, like if you keep your version number in a file, or you can go out and reach for your README or the license in a dynamic way. Whereas with the setup.cfg, there is some, you see the green part there, the file.readme, there is some fancy terminology here that it will go and find files for you, but it is still essentially static. I don't know, most projects that I've seen have veered towards the setup.py because they have that flexibility, and sometimes it's just easier working in Python. So that's how it used to be, and then there was this. If I could have worked out, this isn't really a reflection of Canva, but if I could have worked out how to add the sound effect for the halo, it would have gone along with this. Now, there's a Frenchman who obviously had the same frustrations with setup.py and setup.cfg and all of the other crap that I did. So he's gone and set up this poetry project, and it solves so much more than just publishing. It's kind of crazy. So environment management, so things, virtual env, this will do it for you. You type poetry shell and it will create a shell in a cache temp directory in your computer based on a hash that it can relook up, and just you're in it. Dependency management brings everything that Python had been missing from, compared to something like Node, where you had npm or yarn providing lock files. You had dependency resolution that was less garbage, and adding support for scripts. Unfortunately, the scripts are only Python. I mean, you can call out to other stuff from the Python, but it's a little bit of a runaround. It's still very handy though. So you can run poetry run PyTest and it'll just do that for you. Publishing, so that's the stuff that we're talking about today. It's very convenient. Like it makes you wonder why anybody did it this way. So I guess let's get into that. Now I'm hoping that this goes all right. So what I'm going to do, bear with me. Okay. I'm going to remove all of that. We've got, oh, lovely. So I'm hoping that you can vaguely see what's going on up there. All we've got here, and ignore the yellow stuff, we've got an empty repository as we would have created with GitHub. It's done the license, it's done the README, and a git ignore. I just picked Python and it's worked out with, I haven't had to add anything yet. So now I'm just going to sort of auto-magically bring in the library code. Again, this, don't get the wrong idea, this took a couple of days to put together in amongst work and stuff. I can't just create code on command. So yeah, you've got the paint file, some hacking that I had to do in order for it to get it to take parameters, those pigments or components that you need to style, and those premixed versions. So what we want to do here, I just want to show off how poetry works. Poetry is a bit of a pain sometimes to get installed, but once it's there, so keep this up. So it's gonna figure out a lot of stuff for us, but I'm going to make some changes along the way. I want to talk about semantic versioning at some point along this journey, and the responsibilities that go along with things like a 1.0 release. But this will save us some time later. That'll do. I've got to remember, this one's always a pain. Sure, why not? Now, it'll ask you to define your main dependencies interactively. We don't really have any for this, and I've tried to do that deliberately. There's a, I don't know, when we look for packages to rely on at work, at Canva, there's a tendency to look for things that don't rely on too many other things, so we don't have to go chasing upstream problems. So I'm just going to say no for that one, and no for this one, because I want to show you how to add. We do have one dev dependency, and you can see it's gone and generated this for us. I think that's okay. And now we've got this pyproject.toml. Now, we will add stuff to this as we go, but that's pretty much all you need. And you can now do, I guess, I will wait to show you adding the next lot of stuff. Just a moment. Okay. Okay. Now normally, actually, cool. So I'm going to add a dependency manually. Now, like Yarn, it doesn't encourage you to add them in here. You can go in and add dev dependencies manually if you want to, but it's discouraged. So let's go and add PyTest. I'm not a big fan of the standard testing library that comes along with Python. And you can see here it's created this poetry.lock file. And all that is it's the same thing as your package.lock from the JavaScript world. It's just resolving the dependencies in a way that should be replicable. That's okay. I've made it. That should have been added as a dev dependency because the code doesn't actually rely on it, but we will for tests, but I can fix that later. But what I will do is step 2. Me. Okay. Now, testing is a big part. Like if you want people to use your library, if you want people to rely on your library, the expectation is that there are some tests and that those tests cover the basic functionality. Again, it's not necessary, like you don't need to add tests, but it's always a good idea. And if you're using this talk like I intended for developing a project for your CV, for showing off to your prospective employers, then it's always a good idea to show that you value testing too, because there's a good chance that they will. I don't know, unless they're a blockchain startup or something. So with those tests, I've imported some stuff. I've got expected text. Now, for those paying attention, they'll realize that this doesn't include what it should in terms of the ANSI escape sequences at the start, but I had some issues with CapSys, the Python or PyTest fixture that captures standard out, and I'm still working on it. Cool. So we've got some tests. You can have with PyTest, again, I'm trying not to assume too high familiarity with the Python ecosystem, but you can have your tests either in classes, which sort of give them a convenient unit to run by, or you can have them sort of externally. And you can see that if you set up your PyCharm or your VS Code or whatever correctly, it'll let you run tests. And because I've stolen some stuff, that one may not have worked. Yeah. But moving on. So it's done. We're getting to the point where we need to start talking about actually publishing stuff. Now this diagram is from the Python packaging tutorial, and I think it does a really good job of explaining the differences between these. You can ship modules that will generally work. So that's the .py. They're generally transportable. There shouldn't really be any issue with you just giving someone a .py file and them running it on their machine. Dependencies and version issues aside. You've also got SDIS. So if your Python library that you're creating or package that you're creating is purely Python, it doesn't rely on anything else, there's no Python extensions, then you can create an SDIS, and that's sort of understood to be a perfectly acceptable thing to accept as a library. When you install via pip, it'll know how to install that. Wheel is more comprehensive. Wheel will let you include non-Python code. It'll let you include Python extensions. There's a little caveat with that. This magic that I'm about to show you with Poetry. It doesn't support non-pure Python wheels, but it does create wheels. It's something that they're working on. But for the most part, it's not... Unless you're doing something incredibly high performance, it's likely not to be necessary. So, a couple of things that we need to go back and modify in our pyproject.toml. We need to make sure that we've set a version. We did that interactively, but it's always good to be mindful of the version, and particularly because if you try and ship a version to PyPI or the test version of PyPI with the same version number as one that's already there, it'll bounce it back and tell you to go away. Description, self-explanatory. Authors, self-explanatory. License is important. If you want other people to use your code, if you want other people to feel comfortable using your code, you need to have some sort of license. There is a really good website that I can link in the events channel for choosing a license. It's realistically, unless you're an organization, the nuances of the differences at least with the common licenses that you see in open source, are a little bit moot. But I don't know, I use MIT and BSD3 almost exclusively for my personal stuff, and the open source stuff that I do through UQ is all Apache too, because it has more legalese that made the lawyers happy. And the other thing is classifiers. So classifiers are this thing, maybe not unique, but very core to PyPI and classifiable. Defining how packages and their use cases and what they run on, and we need to set some of those as well. So you can set operating systems, you can set Python versions, you can set the core focus of the library like I've got here. It's not going to get as niche as like coloring font perhaps, but they are good at communicating to prospective users why they should use your the library that you're making. So I mentioned the test version of PyPI. This is where we will start out with today, because you can ship stuff there and there's no expectation that it's working or that anything is going to go well. And yeah, let's. So, I've gone in here, we've made sure we have a name, version, output, license, home pages, not particularly necessary. Repository is handy. Most of these things are sort of rich text linked in PyPI, so when people find your thing on PyPI, they'll be able to follow it through. I found it incredibly useful to be able to, like if I'm having trouble with the library, being able to go to the GitHub link and look at the code to see what's going wrong. Now you can see PyTest is back in dev dependencies where it should be. And this build system, that was automatically set when we created the project, but it's very, I guess you're about to see how convenient that masonry system actually is. So let's do a poetry build. So these two steps that we're about to do replace a bunch of commands that you would have run with setup tools and twine historically. So you can see here that it's created an sdist and a wheel. So it's created both because it's sort of recognized that there's nothing non-Python in there. And it's populated this dist folder. And you can see that's ignored by the version control system very deliberately, because you typically don't want those artifacts hanging around, and they can get quite big depending on what you're working on. So the next thing is poetry publish, and what that's going to take it to bear with me. We're going to go to test PyPI first. So we have to do this. There's one line of config here, and we're setting repositories test PyPI to this URL, and that URL points at the other one, the test version of PyPI. So we want to set that. For some reason that I don't know or understand, it doesn't appear in the pyproject.toml. But yeah, now we should, in theory, be able to poetry publish. Oop, not if you spell it like that. we've hit a snag. So we need to go to test.pypi.org and set up an account so that it can tie the releases that we make to us, and people can't, I don't know, hijack the project and steal the namespace. So if I log out, you'll see what you should. So here you just need to go and register. It's a very straightforward process. And you can log in and you can see things that you've created before. So in this case, Slackblocks, the project I was talking about before, and this new project, House Paint. If we go and have a look at that, I created a release 0.0.5 a little while ago, and you can see here it's taken the README, and I'll talk more about that in a moment, and populated all of these links with the information that you gave it. It's auto-populated some classifiers like the version and the license, and so if I go in here, I can see which versions have been created. Now I've deleted the 0.0.1 version so that I can push this. Otherwise it would get potentially cross at us because it already exists. So what we need to do in here is put in our username and the password that I do not remember. Oop. File already exists. Okay. I wouldn't recommend being this blasé with like your own versioning, but bear with me. So we've got a poetry build. Just delete these just in case. Okay, there we go. So now we should see I was publishing to the wrong PyPI. Yeah, so when you publish, there's a -r flag, and you can go test PyPI. So that's something like, I guess with the ease of all of this, it's also easy to screw up. You're kidding me. Another gotcha. PyPI and test PyPI are completely separate. They don't share authentication information, so they will use different passwords. Wait. Okay, I'll skip pushing to test, but that's our goal was to get this up here, right? We've got a release. It has things in it. We can go and control the release. We can yank it, so pull it from distribution if we need to. We can delete it, which I've been doing all day as I've tried to get this working. Didn't quite work out, but we got there in the end. So now that the release is created, we can go back. Oh God. when we, there's a little bit more to this demo. So when we create a release, we can do that manually. Using the username and password is fine, right? For us manually doing it, I guess the ideal though is that we wouldn't be manually doing it. That we would we'd make some changes to the code, and some other platform would take care of this responsibility for us, right? So the next part of this talk, I want to talk about CI for this particular workflow. So again, ideally you've written some tests. We would like to run those tests every time you commit code, right? It's good practice. We're going to set up a couple of CI workflows, and we're going to use GitHub Actions because it's reasonably straightforward. It's already integrated. You don't have to fiddle around with API keys. And we're going to set up 3 of them, or at least 2, depending on how we're going for time. So you can see here we've got our tree. We've added our PyProject.toml. We've got some tests. We've got our house pane. I've added in some information in documentation. That was sort of step 4, but I will cover that in a minute. This is the code from the test.yaml. In GitHub Actions, you have this .github hidden folder, and it just defines a bunch of workflows. So for us, our workflows are going to be, we want to test the code, we want to publish the code, and we want to publish the code to the test version of PyPI for whatever reason. So you can see here, it's the YAML isn't particularly helpful in defining nested stuff, but what's happening here is we're going from on, so every time that there is a push to branch master or a pull request to master, we're going to run these jobs. It doesn't really look like it says that, but that's what it says. And we have one job here in the job section. It's going to run on Ubuntu, so we've chosen a Linux environment. You can also get Mac or Windows environments depending on the CI provider. It has a couple of steps. So this @users is a thing sort of, it feels almost unique to GitHub Actions, but there are other implementations. But what GitHub Actions has allowed people to do is readily share these predefined parts of workflows. So in this case, Actions is a group, an implementation, a GitHub organization that implements some of these workflows. And they've implemented one called Checkout. It's a version 2. So what that's going to do is take your code and check it out. They've implemented another one called Setup Python, and that does what it says. It's implementing, downloading and installing Python version 3.9. And then the next one is done by somebody that isn't GitHub, and that's their GitHub username /setuppoetry. And what that's doing is installing Poetry, which can be a bit finicky depending on the platform. It's then running Poetry install, so that's setting up your project, so installing all the dependencies, in this case PyTest, and then it's Poetry run PyTest, so it's going to run the tests for you. So let me briefly talk about the README first, and then we'll get back to that. All right. So READMEs are very important in the open source world for various reasons. It's a way to communicate everything that your library has to offer. It's the first thing that comes up when you go to GitHub for a library. It's what gets imported into PyPI. And your job in that is to explain what your project does, what requirements it has, so outlining any dependencies it may have. If there are a lot, it's less, you might direct them to a requirements.txt or the pyproject.toml file. But it's important to communicate sort of what these people are signing up for if they use your code. You'll typically talk about installation. Again, you can sort of go above and beyond as to like how you describe or how thoroughly you describe this, how many options you support. In this case, I just wanted to make it clear that people could use poetry for this. Poetry points at PyPI too. It's not anything different, but it's, I don't know. Poetry has been very convenient for me, and I'd like more people to use it. You need to talk about usage. So, and you can normally do that with a couple of code snippets that outline the core behavior. Once your library gets a little bit more in depth, you might start thinking about auto-generated documentation. So in Python, that's normally done by a library called Sphinx, and you can set up a workflow to do that too. You can build it and then push it, or you can have Read the Docs, a company or a website that hosts a lot of free documentation, build it for you based on GitHub hooks. And yeah, it's good to show off what it does. Sometimes that's easy. Sometimes you can just have a single screenshot, or you can include GIFs in these. I like to be upfront about any limitations that anything that I'm building has. I don't want people to get the wrong idea. I don't want to feel like I'm on the hook for creating something more than sort of what I've already laid out, unless that's my goal from the start. All right, so we've done that. We've got a README. Oh, the other thing, I have to shill the company at some point. The logo took me like 2 minutes in Canva. So originally I was going to say, oh, this is the most optional part, but realistically it takes no effort, and it helps you stand out from the bazillion other projects on GitHub. Okay. So I mentioned those workflow files, so that was just one example. And I'll have a look with you through the other examples as well. So let's just talk about it in its easiest form, just publishing to regular PyPI. In this case, our on is a little bit different. So you remember before we were on pushes to master, on pull requests. In this case, we're doing something slightly different. We're creating, where we're going to start this workflow every time a tag is pushed. So GitHub tags were not something that I had created via the command line before very recently, but it comes back to this semantic versioning system, and I suppose I may as well talk about it now. Here, with this system, you typically have a major version. So, and I guess the most common place to see this is with Python. So you might have Python version 3, so that's the major version. The minor version is 9, and the patch version is 1. I think in this instance of Python that I'm using. So here, we want to catch any tags that match the format V and then some semantic version number. It's going to run on Ubuntu as well. It's going to check out. It's going to poetry publish. And now this is I guess why it's very convenient the way that GitHub Actions has been set up. There is this existing action that does everything we need, and all you have to do is give it a token. Now, the tokens are slightly different than the username and password that we used before. You only really need one piece of information. So we're going to settings for our project on PyPI or test PyPI, depending on where you want to go, and you can create these tokens. So you give the token a name, so we say this is prod PyPI for house paint. And you can choose a scope. Obviously you want the most limited scope you can typically, so that if someone does find it out, they can only mess with one of your projects. And you'll notice here it says this token will only appear once, so you want to grab that and you want to stick that in here. So from your GitHub, you can see this is on master, but the secrets are universal. So we go into settings, we set secret, and I can add a new secret. You give it a name. That name has to match what's in your workflow. So I think in our case that was PyPI token. And you put the value in there and add the secret. Now I've already done that today, so there should be one there that works for that. Now, how do we trigger this? How do we get this to work? So we've written our workflows. We've got this one. The publish test is identical. It's just looking for a T at the start and pushes to a different repository. So we'll focus mainly on this publish one. So let's assume that for argument's sake we've pushed those workflows to GitHub. Those workflow files are there. Now all we need to do is let's just so that I don't have the same problem as last time, let's dump that version, and again avoid being this blasé if you can. So we want to now git tag, and we'll 0.10. Okay. So now you can see that it's actually, bear with me. We should commit the version change. It's an incredibly painful problem keeping the version consistent. I'm sure it's solved somewhere, but I have yet to find the solution to that. So let's. Oh, okay. This is what I get. All right, so we've committed our changes. We want to create that tag. I'm just going to force it because I've already created it. And now we want to git push tags. Now, when you do a regular git push, it doesn't push the tags by default. So you have to do that separately. So you can see now it's pushed that new tag, and while we're here, I'm just going to do a regular git push so that it pushes the code, and we can see the testing workflow as well. So if we go into actions, you can keep track of all of your jobs. And you can see the stages of this build as it happens. So there's like some of these predefined GitHub actions can do a lot, and sometimes it's difficult to debug, but it's sort of the price that you pay for the convenience, I suppose. So you can see here it's installing everything that it needs. And we've got the green tick. So now if we go to PyPI your projects. House paint, blast released half a minute ago, that's a good sign. And we've got our version 0.0.10. And it's just there. So you can control this rather than going through the effort of finding the password and using the username, and like it just sort of works for you. All you need to do is create a tag and push it. So you've got this additional control over the workflow. Now if I go back, you can also see let's have a look at this one for an example. I wasn't on the master branch, so it didn't trigger when I did that git push. But you can see here, it's gone through, it's run the checkouts, poetry run PyTest is what we're after. So 3 tests passed, and that's what we want to see. If that step had failed, the workflow wouldn't have completed. Ideally, what you'd do is run the tests first, and you'd set these steps up in sequence, perhaps as part of the same workflow. This was, I guess, just an example. Now, if you've done all this, if you've gone away, you've made your own project, you've gone through and you've made a nice README, you've got tests, you've got the CI working, there are more things. This is sort of an infinitely expandable thing. You can go and test across multiple operating systems. You can test across multiple versions of Python in what they call matrix testing. There are GitHub Actions for that. And it's sort of built into the GitHub Action system itself. You can include a step for type checking. Those types that we added can be far more useful if they're telling you about problems with your code in advance. For me, I just like the convenience of it telling me in the IDE, but it's a part of the workflow where I work and at other companies that I've worked at as well. You can include binaries in those distributions, so you can have it produce something. So when you run Flask, you typically do Flask run some app, and that Flask object is a binary that you have to create or insert and include along with your distribution. Python, so you can also include C code, so big libraries like NumPy and SciPy, where they're doing a lot of matrix operations, they rely on C extensions, so you write C code and call down to that C code from your Python using Python. You can also add automated linting, so that's along the same lines as MyPy. This will tell you where you've done things wrong, clean up, or tell you to clean up code smells, make sure you have your new lines at your end of your files, and yeah, I guess the last bit I already mentioned, you can have documentation generated automatically from you. If you comment your code in a particular way, it will sort of scrape through that code and produce HTML documentation, so people will know how to use your library. That's it from me. Thank you all for your patience. And yeah, it was a pleasure to come.
Chair, right?
Hello, Nick.
Hey.
Thank you so much for coming back. We know it's a far journey from Sydney, but
Good.
Here's a mug for your troubles. So
Thank you.
Give them a round of applause. And yeah, don't forget, Friday we have Math and CS talks with MSS. We have our lovely Bradley Stone and also Chelsea doing a talk as well, so make sure you come along. Other than that, thanks for coming, and Pizza will be up at GP South. So
That's why I really came.
Well, you had said this is the last time. Go and find somebody else next time.